Hi everyone, welcome to day 3 of Neon Developer Days. The past 2 days have been full of excitement. So on day 1, we announced that Neon was live, so you can go ahead and try it at neon.tech. And we also announced the availability of our branching feature, which we explored a little bit more in depth in day 2. And today I'm very excited to be joined by George MacKerron, the creator of Zapatos, the TypeScript library for Postgres, who will talk today about his work with the serverless WebSocket driver for Postgres.
Hi, Ralph. Good to see you.
Good to see you, George. Thanks for joining us today. So I'm going to hand it to you. And
That's great. So I've got some slides here. I'll share my screen.
Okay. So
that's great. So serverless has a bunch of benefits, right? Serverless means it's quick and simple to deploy your work. There's no servers to maintain or manage. It means that you can scale really to meet very large demand, generally without breaking a sweat. And on the other hand, it means that if that demand doesn't come, or until that demand comes, generally you're not paying over the odds for some enormous machine that's sitting there idle 99% of the time. And Neon, of course, offers serverless Postgres, right? We kind of bring those benefits of serverless to your database, which is great. And it's only natural, I think, in that case, that people who are using Postgres serverlessly would like to connect to Postgres serverlessly from Cloudflare workers, from Vercel edge functions, from a sort of growing range of different ways of doing your kind of serverless compute. But there's a little bit of a problem here, or there has been a little bit of a problem here, which is that these platforms, these kind of really nice, lightweight serverless compute platforms that tend to be based on V8 isolates, they don't talk TCP. And of course, TCP is generally how you make a Postgres connection, right? And so until now, there's been this kind of somewhat unfortunate choice. You could have a serverless database, or you could have serverless compute, but you couldn't make the two talk to each other, so you couldn't generally have both of them at the same time. And I'm happy to say that we're solving this problem. Certainly we're solving it for Neon with this serverless Postgres driver. And so what we've produced here is a driver that's based on the standard Node Postgres Postgres driver, what you get if you install, if you type npm install pg. But we've changed it, we've sort of shimmed a little bit so that it now communicates over WebSockets. So it sends all that traffic that would have been TCP over WebSockets. It currently works in Cloudflare workers. It also works in web browsers, and that's quite useful for debugging. You get more feedback more quickly debugging in the web browser than you do in some of these cloud platforms. And you can also imagine cases where it would be useful to be able to communicate with Postgres in the browser. The issue here is that the Postgres credentials for connecting to the database are in the browser, so they need to be credentials that you're happy to share with the user. But there's cases there where, for example, if you were building an online IDE and those credentials are the user's own database credentials, then it's fine to use our driver that way. So if there's one thing I want you to take away today, it's really just that where you would previously have typed npm install pg, you can now type npm install at neon database /serverless, and that will install our kind of adapted version of the PG driver that will talk to Neon over WebSockets. And you shouldn't need to do anything else to make existing code or the code that you would write the normal way work as if you're using the PG driver. And actually, that command, that package, the Neon database serverless package, also includes the TypeScript types, what you would normally get by installing at types/pg. So that's kind of should be all you need, is just to install that new serverless driver that way. And I thought the kind of most straightforward thing to do here would just be to do a really quick 2 or 3 minute live coding demo, just to show you how quick it is and how simple it is to get up and running with our serverless driver. And once we've done that, I might kind of briefly show a bit more of a complicated demo. We won't go through the whole thing in that case, but show something that's a little bit more kind of solving a real world problem. So the kind of live coding demo is just something really simple where we're just going to ask Postgres the time, right? We're going to do a kind of select now query. And so what I need to do that is, let me bring up my terminal. Here we go. And so when we're creating a Cloudflare worker, we use the Wrangler tool. So I'm going to type npx Wrangler, start a new project within it, and let's call this Neon Cloudflare Demo. And we'll wait for a moment while it does its thing there. I'm going to say yes to all of the defaults here. Yeah, fetch handler is good. And we'll wait for a moment while it does its thing. And then the next step in a moment is that we're going to go into the directory that Wrangler has created for us here, and we're going to go ahead and install that serverless driver. So let's do that now. Let's cd neon cf demo. And as I said before, instead of where we would normally type install PG here, we don't do that. We do neon database serverless. Okay, so we're set up now with a Cloudflare worker set up and the serverless database installed. And the final thing that we need to do before we can write some code here is to tell Cloudflare workers our credentials, find a way to securely provide our database credentials to this Cloudflare worker. And we do that again with the Wrangler tool. We want to put our secrets. So we do npx Wrangler secret put, and we're using a kind of Heroku style database URL setup here. So if I type that, and then I'm just going to go off screen and copy these secret credentials. And it's ready for me to type them in or paste them in here. So that's those pasted. Let's just start loading those, I think. That's great. And then the last thing, of course, that we need to do is write a little bit of code that connects the database. And as we said, asks at the time, does a select now. So what we're going to do for that is we're going to edit the index file that Wrangler created for us, and we'll edit that in VS Code. So that should pop up here. There we go. Now I'm going to delete what's here already. And we're going to start this from scratch. So the first thing I want to do is to import the database client from the serverless driver. That's there. Then I am going to just tell Typescript not to worry about our database URL driver. I need to use the right kind of brackets here, don't I? But we've got this environment variable type here. And I'm just going to tell it that it should expect database URL to be a string. So that's the credentials that we've set up via Wrangler. And then we've got a kind of module style worker set up here. So we're going to export a default object, and that default object should have a fetch method looking like this. If I spelt it with the right letters, that would get us a bit further. And that takes a few arguments. It takes a request, it takes an environment, which has the type that we just defined, and it has what they call an execution context, which actually we will have a use for in a minute. Okay, and now of course the first thing we need to do is actually create a database client. So let's create a variable called client, and we'll assign a new client to it, and that client should connect via the database URL that we set up. And of course then we want to connect it, so this is an async function. We can await the connection here. We just do client connect. That's good, and now we can actually query it. So we're going to do a slightly complex destructuring assignment in a moment, but the key thing we want to do here first is just run the query. So client query, and I said we were going to ask the time, so let's just do select now. And then to assign that, we're going to end up with an object that has an array of rows, and the first and only row is going to have a column called now. And so if I do a destructuring assignment of that sort, that should assign that current time to the variable called now. And what we're going to do at the end of this run is just return a new plain text response with that now variable. But before we stop and run that, the other thing that we should probably do is just close the database connection. And if we use the wait until method on the context, that doesn't actually delay the response being returned to the user. It just delays the worker from halting, from stopping until that's been done. So rather than doing an await, which we could do, but that would slow the response down a little bit, we do a context wait until instead. Now that should be all that we need. So we should be able to just deploy that all around the world now by doing npx wrangler publish. Let's see if that works. So it should be bundling this and uploading it. Nearly there. And it's given us a link that we can visit that. Let's see if that's now working. This should tell us the current time on our Postgres server. And so it does. There we go. That is the current time on Postgres. So that's the kind of a really basic coding demo. You can see that you can use this much like you can use an ordinary Postgres driver. There isn't really any big overhead to using that. The other demo that I thought I might show is something a little bit more complex, something a little bit closer to something that might be useful in the real world. And this is an example that combines IP address geolocation with Postgres, the geographical information systems extension for Postgres that can do nearest neighbor searching for us. And so as an example data set for this demo, we've picked something that kind of is useful all around the world, and we show your nearest UNESCO World Heritage sites. Of course, you can imagine lots of other different kind of applications for this setup. A sort of classic one would be, I think, showing the nearest store of a particular retailer on that retailer's website, perhaps on a map. So I can show you the app for that one. First of all, the app is this. And I'm sitting now on the south coast of the UK in Brighton. And so, yeah, the IP geolocation has me in just the right place. And it is showing me my nearest World Heritage sites, some of which I've visited, some of which I've never been to the Tower of London. I was very close to the Tower of London on the weekend, but I've never actually been there. That would definitely be one that I would like to visit one day, and that will take us to UNESCO for more information if we want that. And if you want to see where that comes from, I mean, the structure of this app is very similar to the app that I just showed you. In fact, we start again by importing the serverless driver and defining our database URL. And then in here, we access the CF property Cloudflare provides on the request object. We look for the longitude and latitude on that. This is a little bit more complicated here because we also allow you to provide the longitude and latitude within the URL so that you can use your browser geolocation if the IP geolocation for any reason fails or isn't correct. And even if neither of those are available, then we sort of fall back on this San Francisco longitude and latitude. So we start by taking longitude and latitude from somewhere. Then we just check if we've ever cached these results so that we wouldn't even then need to hit the database. And we round the longitude and latitude to about 2 decimal places. So that gives us sort of your location to within about 1 kilometer. So if someone requests their nearest heritage sites within the same kilometer or so that's been done recently, then that can come straight out of Cloudflare's cache. Doesn't need to go to the database. And then the kind of the meat of it is we use the longitude and latitude here as query parameters to this kind of basic PostGIS distance query, where we select the ID, the name, the category, and then critically the distance from this table of World Heritage sites, and we order by the distance and take only the nearest 10. And then finally, if that wasn't already in the cache, then we cache it and we return it all as a JSON response to the client. So that's our second demo. And as I said, you can visit that site and see if there's any World Heritage sites near you that you still need to visit. How does this all work? Well, it's kind of the basic idea, as I said before, is quite simple. We run a kind of basic WebSocket to TCP tunnel or proxy, and we redirect the normal Postgres wire protocol straight through that. So the driver connects to the proxy over a WebSocket. It tells the proxy which database host and port it wants to reach, and the proxy then opens a TCP connection to that host and port, and from then on it just relays traffic in both directions between the driver and the database. And there's a key advantage of this solution over some other ways of fixing this problem, such as HTTP fetch-based drivers, which is that you get a real ordinary Postgres connection via an ordinary familiar Postgres driver. And that should mean that sessions and transactions will work as expected, and any existing code that expects an ordinary Postgres connection should require little or no change to work with our serverless driver. What do we need to do to make this work? Well, as I mentioned at the beginning, the driver is based on the sort of standard Node Postgres driver, which is called Node Postgres. It's what you get when you do npm install pg. But to make that work, because that's a Node driver, and the sort of the full Node environment typically isn't available in these sort of serverless compute facilities, we have to sort of provide some shims for the Node.js library that Node Postgres expects. And that includes some sort of small, simple things. So for example, we can replicate Node's string decoder object using the text decoder object that you find in browsers and in V8 isolates. We can shim Node's URL parse method using the kind of more modern URL API, and so on. But the key part of the work, unsurprisingly, is in replacing Node's NetSocket and TLS Connect. And in NetSocket, of course, we redirect all the traffic that would normally be going over TCP to go through a WebSocket that we open. And in TLS Connect, we make sure that all the data that we send over that socket is encrypted and authenticated, so that we know that we're talking to the right server and that no one else can listen in to that traffic. And currently, we do that by compiling the wolfSSL TLS library to WebAssembly. And we also use some crypto callbacks that wolfSSL provides, so that we can offload some of the hardest work of encryption and decryption and hashing to the JavaScript subtle crypto API for slightly better performance there. So it's a combination of wolfSSL compiled to WebAssembly with Emscripten, and then calling out again to subtle crypto for some of the most intensive crypto work. Neon is a big fan of open source. All the stuff that I talked about today is available on GitHub. The addresses are here, so you can see what we've done. You can build on top of it, you can fork it, or you can actually use it to make your own Postgres instances accessible over WebSockets. So the proxy and the driver are both fully configurable to enable you to run your own proxy and connect from the driver to your own database instances via that proxy. And there are details of how you can do that actually within the readmes of these repos, and also in the blog post that sort of accompanies this talk. And that's really most of what I wanted to say today. So thank you for your attention, and I hope you get on really well with using the Neon serverless driver to communicate with databases from serverless compute.
Thank you, George. This sounds fascinating. Is this is open source, right? So I can technically try the proxy myself.
Absolutely, yeah. So you can run your own instance of the proxy today. You can run it locally for development, or you can run it in production to connect to your Postgres instances anywhere in the world.
Okay. So, and what's next for this driver then?
So we kind of top of the list is make this work on a wider range of different serverless platforms, edge functions, and so on. And then sort of number two is, or maybe in parallel, maybe there's joint number ones, try and kind of improve the story around CPU usage and latency, because to set up an SSL connection to the database takes a few round trips. We have some ideas for reducing the number of round trips there, and also we may kind of in the short to medium term use a different TLS solution than compiling wolfSSL to WebAssembly. So we'll probably get slightly quicker and lower CPU usage connections if we can either just use sort of native secure WebSockets and then tunnel an unencrypted Postgres connection through that, but that's okay because the WebSockets will encrypt and authenticate the connection. Or possibly we could use a sort of a subtle crypto only TLS connection. So we might be able to do this kind of sort of a kind of simple JavaScript wrapper that then calls out to subtle crypto and doesn't need the WebAssembly. Because actually one of the obstacles to wider compatibility of the driver is that different serverless platforms have slightly different conventions for how you import and run WebAssembly code. So if we can do away with the WebAssembly code, we can probably speed things up, and we can probably get wider compatibility in the same stroke.
Because the example that you have is working on Cloudflare workers, but obviously you want that driver to be working in other serverless platforms.
Absolutely, absolutely, and soon it will be, and we'll have more news on that soon, I think. And we'd also, of course, like to kind of minimize CPU usage. Because we'd always like to minimize CPU usage. It's kind of better for energy use. It's better for our pocket. But in addition, at the moment, this tends to take around 30 milliseconds of CPU time for a short query on Cloudflare workers, and that's comfortably within the kind of the first paid tier of usage, but it's not comfortably within the free tier. I'm not sure that we'll ever get it quite down within the free tier, but the less CPU you use, obviously, the better for everybody. So that's another one of our kind of key aims here.
That's exciting. So the first stage would be to cut down latency as much as possible, and then like going to as many platforms as possible, so you can have actually this driver working with.
Absolutely, and as I said, actually, that some of the things we could do might sort of address both those goals concurrently. So yeah, I hope to have a lot of news on that soon.
Awesome. Well, thanks a lot, George, for this presentation. Go check it out. Go check out the serverless driver at Neon Database /serverless. Try it out. Let us know what you think about it. And go try out Neon too, neon.tech. And we'll see you guys in the next video. So thanks a lot, George, again.
Thanks, Rav.